Morning. So we are in the second last module for the semester, and the module we're going to cover is internal class design. It's the next portion of class design. So you will see the presentation material was updated a bit, and we're going to cover defining operations, methods, states, and attributes. There's another module which will cover the dependencies, association, generalization, use case correlations, all of that also, but for this week, we're going to look at those sections. Now, for the first thing is we have to look at how do we define operations and where do we get the operations from. Initially, when we had our sequence diagrams, we had messages going between the lifelines. Now, these messages are going to be translated into operations. But we also might need to go and look for special cases if we need to manage some special functionality. If there is need for us to copy a class or create a copy of an object, then we might need to make a special operation, because that wasn't initially in our diagrams. If we need to test for equality, we might need to incorporate it there. So there's a bit more about it. We can go and study the responsibilities of our corresponding analysis classes. We can go and look at the initial operations or initial messages and then create operations based on that. We can use the description of the responsibility as the initial description of the operation to say, but this is what is going to happen there. Okay, so there's a bit more information. But then they go on to say to us, how do we name operations? And especially when we name them, we need to look at a few specific things. Okay, we need to indicate the outcome of the operation or based on the outcome. We also need to use some client perspective. Then we must be consistent across our classes in terms of our naming. If that same operation is going to be used later on, we must apply it consistently. So then they also mention about how do we define the operation signature. Now, operation signature is the name of the operation, but then in brackets it normally takes in the parameters and the data type of the parameter and the direction and the returning data type of that actual operation. Okay. Now, not all languages support the direction of parameters which you're going to pass into it or out, or even bidirectional parameters. Okay, so then there was a quick discussion about naming operations. Now what you see, they are saying to us it must be done to indicate the outcome. If we look at based on get balance compared to calculate balance, what is the outcome from that? Is it to receive a balance or is it to get a balance? Ultimately, it will be to get a balance. So they say if we're going to read a property, and a property is an attribute or a field which we're going to read through the getters and setters, we will use something like get balance. Okay. If we're now operating in terms of the client perspective, and we're looking at get balance again and receive balance, what do we see there? What is the client going to do? If we look at a sequence diagram, what do we see? We normally see something like this going around our block there. Where's the client? Client is the guy on this side. And what about on the right hand side over here? This is the supplier. So the supplier is supplying the whole operation to the client. But what they're saying to us here, we should work based on, we should name it based on the perspective of the client. So what is the client going to do or get in this case? Is he going to get the balance or is he going to receive the balance? If we look here, when you invoke the message, you're going to say, if we had to name that line there, will it be get balance or receive balance? Receive balance is past tense. You're going to receive it in that sense. It's not a very active phrasing. So in this case, what we are going to see is that will be rather named get balance. What is the client going to do? But from the client lifeline to the supplier. Is he going to receive the balance when you invoke this, or is he going to get the balance? Take for example, if you go to an ATM and you're selecting to see your balance. And when you go through that whole process, are you going to get the balance or are you going to receive the balance? But is the ATM not firstly going to get the information to display it? So it should be done based on the user's perspective. What is the client in that case doing? The client in that case might be waiting to get the balance. If you say receive balance, then it is a matter that he has invoked this and he's going to receive this information. Okay. Then there's also a continuation about operation signatures, where they talk about that we need to look at what are we passing around in terms of our parameters. In our parameters, we need to look at, are we passing values or data by value or by reference? Okay. Is it changed by the operation? Is it possibly optional? Is there possible default value if it's not specified? And then is the invalid parameter ranges or even valid parameter ranges which we need to check and add into the operation. Okay, so then they tell us it's also better to pass fewer parameters and rather to pass object than specific attributes or parameters. Okay, keep in mind that when we look at this, a parameter can also be based on an object, on a class. So in essence, you are passing around an object which is composed of a few attributes. That means you pass one thing around compared to attributes, which may in that case be a few things which you need to pass around. Then there's a discussion about operation visibility, where they talk about public, private and protected operations. And what we see is that we need to look at the operation visibility and how it's going to be noted. What you'll see, for example, they're quickly indicating to us the difference. Private is just a dash, public is a plus sign, protected is the hash sign. Okay. When will you see private? When that operation is only going to be visible inside that class. Okay, so it's almost like a small function inside this class. So you can't access it from any class outside. When will you see protected? When you need to access that operation from outside the class, but still in the same package or namespace. Okay. When would you see public? When you need to access that operation from outside the class. Okay. So it can be then in that case anywhere outside which you need to access it. Okay, then there's a bit more continuation about the scope and classifiers of the scope. You'll see these examples to which they indicate this, where they say to us, our attributes are normally going to be private. Why are they private? You remember one of the principles which you touch on at some point is to have your attributes private and have getters and setters, accessors and mutators to access the data, or you retrieve it, and mutators to set the values. Okay, based on which principle does that come from? It covers encapsulation. So where you are hiding away data behind specific operations. Okay. So there's a bit more of this example where they're just showing to us the data types, the directionality of parameters, the data type on which the parameter is based, and then possibly also the returning data type, for example, for those. Okay. Then they talk about quickly defining methods. So what is the difference between a method and an operation? Okay, so what they say to us, a method describes the operation implementation. It is now getting to the finer details about how is that operation going to happen. The operation is really just that signature, it's really just that name, what is going to happen, that. Just a statement, okay. So it's almost like stand up. What is involved in standing up? If let's say we had an operation, move from this chair to that chair, what is involved? Number one, it's movement. Yes, okay, what movement? Push back your chair, stand up. Move to the other chair, sit down, pull in your chair again. Yeah, so that, what are we seeing there? That is a method. Why? Because it covers also for us special algorithms. How are you going to do it? Okay, so let's say you are looking at an ATM or an elevator. Is there special ways in which it needs to decide? Does it move upwards or downwards in an elevator? If we had to do a temperature on an air conditioner, and you had to say, let's say, move up the temperature. Okay. Is there specific things which we need to keep in mind, special algorithms? Okay. Then other things that we need to do, is there objects and operations that might possibly be used inside that operation? Okay. As we said, that a method is really describing the operations implementation. It's not a matter of saying, we have this operation. We are going to get the balance. Okay, but what is involved in getting the balance? If you are at an ATM, what is involved in getting your balance? If you had to do this, let's say if we had to get balance, what is involved in getting the balance? Hmm? Okay, you will get detail. What detail? So we need to access the account. And then? Okay, but we would like to get the balance. Only the balance. What is the balance? It's how much money you actually have available at a specific time. Now as it's middle of the month, how do they know how much money you have available? Okay, it's not something which we normally work with. Okay, so in some cases they need to have the closing balance from last month. What was the final thing you ended up with on the 31st or 30th of the end of the month? What was how much did you have in your account? And then how much possible transactions that you did? Because I need to calculate the balance based on the charges, the bank charges, the debits, the credits. So you see, there's a few things which needs to be taken into account. If the initial operation was just get balance, that's nice. But is there a specific algorithm that they might have to get the balance? Yes. There's also other objects and operations which is to be used. So we need to look at this. There's also how attributes and parameters are to be implemented and used. Are we going to use temporary attributes? Possibly. Okay. Because this section is quite complex in getting the actual balance. Okay. Is there relationships and how is it to be implemented and then to be used from there on? Okay. So those are things that which you might need to consider when looking at describing methods. So we said an operation is really just that statement which you get from your initial sequence diagram, and that's saying that is what is going to happen, like get balance. But a method is now the actual description about what is going to happen. How are we going to get the balance? Okay. So then there's a bit of a continuation where they're saying to us, the method, if it is described, it should discuss how the operations are to be implemented, how the attributes are to be implemented and to be used to implement the operations. And then how relationships are to be implemented and used to implement the operations. Now, this may vary depending on the complexity of use case to use case and how it will be used later on. Okay. Then they are talking quickly about defining state. What is state? What is state? If you had to describe your state currently, what would that be? You are seated. Is that a state? Yes. You are listening attentively. Okay, so now, how does that relate to software development? What are we seeing? In some cases, we need to model also the state and keep in mind the state and the possible transitioning from one state to another. Okay, how do we know that you can register for more subjects? How do we know that you possibly can't register for more subjects? How do we know that you've reached the maximum limit of subjects? Do we just count the number of subjects, or is there a specific state which we're seeing? There's a state. When you come here as a new student, do you have subjects? Are you a registered student? No. When you return, are you a registered student? In January, let's say you come back and when you're adding subjects, are you a registered student? No. Not yet. Now, when you are getting subjects and you're adding them on there, and you've registered the subjects, did you make a change in state? You're a student, but now you've added subjects. Did you change in state? It's almost like boiling water. What happens if you boil water? It becomes vapor. Did you change from being just a plain student when you added subjects? In terms of ITS and the whole student system, yes, you've changed. Okay, now you are a registered student. Okay, because you are registered for specific subjects. Okay, so there are specific things which we need to consider when we're looking at state. Which objects have significant state? How to determine if an object have possible state and what are the possible states? And then how do state charts map to the rest of the model? So what is a state chart? There's an example. We can have a state that will be like student, registered student. What's going to make you go from the one state to the other? What will be, yes, this transition. But what will make you go from just a plain student to a registered student? Adding subjects, yes. So that operation where you go through, or that use case where you start to add subjects, that will make you, yes, that will make you transition from one to the other. Okay. What will make you possibly transition back? Okay, so possibly deregistering your subjects or cancelling everything. End of the semester, what happens in the end of the semester?
You complete the subjects you have registered.
Okay, so you complete them. What happens if you've not completed all of them? Okay, but what we're seeing here is possible states, and we're seeing that there is a transitioning event. There can also be guard conditions and actions and stuff stated onto it. So there may be an initial state where we have initial condition, almost like in an activity diagram. It's starting at some point, and it's going from there to your first state. If we had to model the state of a student at the university, where would we start? We would start at the initial dot. Then we would take him to be a student. Where can he go next? So you can transition throughout the system, and ultimately at the end of this, you can be at a final state where you've reached the end of that state. Okay. So there's quickly a section where we can see the significant or dynamic attributes. What are we seeing here? How do we know, for example, what they're talking about, if a subject is open and available for you to take, and if it's not? What affects the availability? The number of students in the subject? If you have met the prerequisites? Okay, but in this case, they are looking just quickly at the number of students. If the number of students is less than 10, it is still open. That's almost like a guard condition. If the number of students is less than or equal to 10, it's closed. I actually wonder about this condition. If it is now equal to 10, well, it can't be greater than 10. If you can't go above 10, how can it be greater than 10? If the class limit is 10, how can you go above 10?
But that operation can still work.
Yeah. I would say that this, I agree to what you're saying, that notation needs to be changed, and I will look at changing that. So what we are seeing is, if we're looking at a possible modeling where we're a professor to a course offering, or professor to a subject, we might have that the professor is assigned to the subject, and at some point he's unassigned. He's not teaching any subjects. Okay, but that can help us to capture the attributes and data structures later related to this. Because now we are then modeling based on the information we're capturing. So what you'll see, the state, for example, this assigned or unassigned or open or closed, it is a lot related to the actual data which you are capturing. Okay, how do we know if it's open? We look at the attribute, number of students. Okay. So then here we're seeing course offering to a professor. If a professor is added, he's teaching a course. What operations is doing it? Add professor. Remove professor is now removing him from the course. Then he's not teaching anything. So similar to what you mentioned earlier, register for the subject or register subject. What is that doing? Changing your state to now become a registered student in that case. Okay, so there's another example what we're seeing here where they're just showing to us that it's actually related to these operations in there. And then there's a bit more of a discussion about the state modeling and where they give us a full example to this state diagram. Okay, not all of them is this, I want to say deurmekaar or complex. But what in essence, what we're seeing is that there's a starting point, the number of students is 0 and it's unassigned. But when we actually add the professor, he then becomes assigned. This can happen over and over. It can also go from assigned to cancel and then to the final position there, or even from assigned to close registration. Okay. Now what you're seeing is that they can also add, for example, nested areas where we can have boundaries and say, but these two belong together and that section belongs together. Okay. Okay, so how do we decide which objects have significant state? What they're telling us, object whose role is clarified by the state transition. Okay, so what we spoke about, for example, the student. The role of the student in the system is changing based on that transition, the actual state which they're in. If there's complex use cases that are state controlled, okay, if it's not necessary to model objects such as objects with straightforward mapping to the implementation, objects that are not state controlled, and objects with only one computational state. Okay, either the thing is on and working, or it's off and not working. Okay, that is the straightforward options there. Okay, then how do our events map to the operations? What are we again seeing here is we're seeing a course is open and it's full. We might have an operation here in the course offering to add students. Now, one of the things that when adding students, we need to go and check the actual parameter, the guard condition. Have I reached the number of students? If I've reached the number, I cannot add more students. Okay. Then there's quickly a matter where they're discussing attributes. And what we're seeing is that if we have to identify attributes, we need to look at the actual method descriptions, because that is now taking, for example, if we're saying, how do I get my balance? I need to go and look at that information in a bit more detail and say, what possible attributes do I need to store? What do I possibly have which we need to capture for a short time? We need to also look at the states. Is there a state change in terms of the balance? Not really. Okay, so we might need to consider it, and then we might need to consider additional information the class itself needs to maintain. Where can we get that information from? The original use case specification, the noun extraction, the CRC codes, a lot of your analysis information can be dragged in here and identify the attributes. Okay. So then also for attributes, we can go and define the actual name appropriately, the type, and the optional default value if there is a default value for them. Then we can follow a naming convention of our implementation language or the actual stated project. So where you might use camel case or so to name your attributes. Then the type should be an elementary data type based on the implementation language. Okay. You may also then use the built-in data types, or you even use defined data types, or use defined classes as the actual data type for a specific attribute. Okay. Then we need to also look at the visibility, public, private, and protected in that case, to see what is the visibility of a specific attribute. Then there's quickly a matter where they talk about derived attributes. What is a derived attribute? What is an example of a derived attribute? How old are you? Is your age a derived attribute? Can your age be calculated? Yes. Based on what? Your date of birth and the current date. So, in that case, it is a derived attribute. A derived attribute is an attribute whose value may be calculated based on the value of some other stored attribute. So, what will we store? We will store your date of birth. Okay. Do we need to capture your birthday, your age today? No, because tomorrow it's going to be irrelevant. Or 2 weeks' time, it's really irrelevant because it can be calculated. Okay, when will we use derived attributes? When there is not enough time to recalculate the value every time it's going to be used. Okay, that means that if it's so complex to be calculated, every time that it's going to be used, we might possibly store the actual value. Okay. So we need to look at a trade-off between the runtime performance versus the actual memory required to calculate this value. Am I going to put the system to high loads due to the calculation which we might have possibly for a specific derived attribute compared to the actual database storage when we store this value? Okay. Then they are quickly showing to us some attributes which has been defined for the student, the schedule, the course offering. What we also can see is the actual data types which was given, and in some cases there is even default sizes which was specified. Okay. So then there's a few checkpoints. Now some of the checkpoints say to us that is talking about the classes. Is it clearly defined? Then, for example, there's for the operations. Is it easily understood? Is the state description correct? Is there parameters defined correctly? Then there was for the attributes also. It's a single concept, descriptive name. All attributes are needed by the use case realization. Okay. Then there's some review steps to the end of this. Okay. Any questions? Yes.
Can you explain to me the get balance?
Okay, earlier on, let's just go back to it. Earlier on, we had the discussion, just to come back to it, to say that how do we name operations? We should indicate the outcome. We should use the client perspective and to be considered across consistent among the classes. So there was two main things which we looked at. If the operation should be named to indicate the actual outcome, what is going to be the outcome? Let's say you are at the ATM and that use case is in the process of calculating and getting your balance. So now the main discussion was there, are you going to say calculate balance or get balance? From that perspective, what you are doing, the outcome. What is the outcome going to be? That you actually get the balance. Not that from the client perspective you are going to go and calculate the balance. The calculation is going to happen somewhere in this. So if we're talking about the calculation, it will happen somewhere in this block. Just change the color a bit. So that calculation will happen somewhere in there, but it's not going to be the main thing. Okay, so what are we going to get back? What will we get here? We are going to get the balance. The calculation is part of that operation. Okay. Then there was also another matter which we have at the bottom. You should name operation from the perspective of the client asking for the service to be performed by the client. In that case, client. Then we looked at this portion where we saw that we have a client and we possibly also have a supplier, client, lifeline, and he's accessing that operation. What is the client doing? Is he going to receive the balance? Or is he going to get the balance? So in that matter, he is going to get the balance. It is a matter of what information is going to come back to him. Okay. Any other questions?